H2O, water. Okay, so water is going to be one of the outcomes over there, H2O. And then I just look and see, what am I left with? I'm left with an F and a K. And since there's just one of each charge, they drop. Same thing here, they drop off. So it looks like I have KF and H2O. Okay, so that's the actual reaction right there. So now I just showed this, I broke this down so you can see that, but I'm going to show you what it actually looks like. I had a KOH. So this is the actual reaction. Okay, I have this, and when they come together, they break down and they get attracted to each other because of the charges, and the charges over here, when they come together, cancel out, and then I'm left with water and a substance. Okay, now this is important because this brings up one of the basic things about acid-base reactions. Okay, where is it? Right here. Okay, so this is the general format for most acid-base reactions. Okay, you're going to have an acid, which is your red, and I'll move this closer in just a second. You start with your acid, and you're going to react it with a base. The outcome is going to be salt plus water. Okay, now salt doesn't mean necessarily table salt. Salt in scientific terms is going to be any ionic compound. Okay, so when you hear the term salt, you should think any metal plus non-metal. Okay, so I'm going to move this a little bit closer so you can take a look at it really quick. And they have this in your book as well. So you can see an acid plus a base equals a salt plus a water. So here I'm showing it to you in the chemical terms. An acid is anything that has an H plus that it's going to give, and a base is typically that hydroxide, the OH negative, that's going to accept it, and it's going to form a substance, a salt, which is a metal plus a nonmetal, any metal plus a nonmetal, and water. So this is the outcome of most acid-base reactions. Okay? So not everything follows this format where it has an ionic compound as an outcome, but most do. Okay? And this is also referred to as a neutralization reaction because we had a positive and a negative, and they broke down to join, and they got neutralized on the other side. There's no charges over there anymore. Okay? So let's take a look at example 10.2. It says, give the balanced chemical equation that represents the reaction between HCl and RbOH. So I'm going to erase this. It says HCl plus RbOH. And they want me to give the balanced chemical reaction. So they gave me what I'm starting with. So I'm going to say, okay, this looks to be following the pattern. So I'm going to separate these really quick so I can see them better. I know my H is going to be given over here because I'm going to have an outcome of water. So I'm going to stick my water over here. I know that's already happening. Okay? So what I'm left with is my Cl and my Rb. Okay? So I'm going to look on my periodic table and see that Rb is a +1 and a Cl is a -1. And because those charges have the same number, I can just ignore them and stick them together. So RbCl is going to be considered my salt. It's ionic because it has a metal and a non-metal. Okay? So the last thing I need to do is check and see if this is balanced, and this one should be. Okay? All right, so let's look at the next one. It says write the chemical equation that describes the reaction between sulfuric acid and NaOH. So sulfuric acid is H2SO4 and NaOH. So they're asking me to find the balanced chemical equation. So they gave me what I started with, and I'm a good chemistry student, so I'm remembering what an acid and a base is. An acid has the hydrogens to give, and the base typically has an OH. So I'm going to separate those so I can see better. H2 is going to go with the OH, but keep in mind right here, now instead of just 1 to give, I've got 2 to give, okay? So technically it's going to have to give it twice to this guy, okay? So just on the front end, I'm going to note that, okay? So it's going to give it twice to this. So over here, when I put my H2O down, keep in mind, now I've got 2 of those because it gave it twice. Now the reason why I'm showing you this right now is because when you go to balance it and check at the end, this helps with balancing it. It'll help balance it out faster, okay? So I put those over there in the term of water. Now I need to come up with my salt, or my metal plus non-metal. So I'm going to look in the middle right here, and I'm just going to write off to the side what I have. I have an Na and an SO4. Now, Na, I can look on my table and find the charge for it, and it's 1+. Now, SO4, these, if you don't remember, you're going to have to pull from your table that you had in the book in the last module. If you want to print it off and flip it, I don't actually have it with me right now. I'm not going to flip back. But if you can't remember, really quick, let me show you this trick. Let's go back up here. Where did this 2 come from? Well, remember, it just came from being crossed. If I uncross these, okay, this 2 came from up here, and the 1 that's sitting here that you don't see came from here. So really, I can cheat this by saying I know this 2 came from here, and it's negative, okay? But this you should know from working with it. If not, look back at your table. Now, last step, in order to get it right here, we have to do what we learned in Module 8, okay? We take this and we look at the charges. They're different, so we cross them, okay? When we do that, we end up with Na2 SO4 with the 1, so SO4. So that should be a review, coming up with that polyatomic ion, okay? So if you look, we've got our acid, our base, our salt, which is our metal plus non-metal, and our water. Okay. And I'm not going to do that last reaction. I'm going to just move ahead with that. Okay. Always make sure it's balanced. Okay. I know it's balanced because I've done this. But if you didn't take the time to balance it, we're going to have to do that towards the end of this module more. Okay. So go ahead and pause this and go ahead and do the on your own 4. There's 3 of them for you to do. Okay. And then we will come back and talk about reactions with covalent bases. Alright, so hopefully you had a chance to do that and it wasn't too difficult coming up with that. Okay? If you have any questions, we can always make a separate video. Alright, so now that you know how to predict reactions between acids and bases, you can start seeing why they're really useful as household cleaners, right? A lot of the messes you need to pick up are acids, and what do you use to clean them up with? Bases. So they neutralize each other, so that should hopefully help you to see that. Alright, so we are on page 332 right now. Now, let's say instead of having an base that has an OH in it, what if I have a base that doesn't follow this pattern? Because some of them, they're going to have some that don't, okay? So you already know how to use it with the OH, so let's put this off to the side right now, and let's discuss covalent bases, okay? Because the ones we were talking about had ionic compounds, a metal and a non-metal, and now these are going to be covalent, okay? So it's not going to be much different. Let's say I have H2SO4 plus H2O. Okay. 3O and SO4. Okay, so let's take a look here. I can see that I've got an acid right here that has hydrogens that it's going to give away. But when I go to look at my base, all of a sudden now I see it doesn't have an OH. It's got 2 H's and an O, it's got water, okay? So this is a little bit different. This is covalent, which is the same thing we've been doing, but instead of being ionic, a metal and a non-metal, it's 2 non-metals. It's it's covalent. Okay, so we can still do this. Just keep in mind that it's just going to look slightly different. You're not going to be able to look for that OH and be like, oh, that's a base. But still the same thing applies. If we look right here, I'm asking, where does this hydrogen go? And if I look over here, I should see that it used to be H2O and now it's H3O. So I know that it's going to give it to that guy, which is what it ends up as. Okay? So that means that this one is going to be all by itself. And is it? Yeah, it is. It's over here. Okay? So if I'm looking at this, it's the same process. It's just you can't look for that OH. Okay? So let's look at the two examples here. And we're keep in mind we're doing the same thing that we were doing. Okay? So it says what reaction occurs between H3PO4 and ammonia, which is NH3. That's the base. Okay, so they're asking what reaction occurs between those two. So right away I'm going to say, okay, this is the acid because it's got the hydrogen. And over here, I don't have the OH to separate. Okay, this is covalent. So I'm just going to say, okay, well, where is this H going to go? Okay? So I know that it's going to go over here with this guy. It's going to add one hydrogen. Okay. So on this side, I'm going to write it out that way. NH4. Okay. Now there's 3 of them here though, so I know that it's going to have to do that 3 times. It's going to give it to this one 3 times, and I'm going to notate that by putting a 3 out front right here and a 3 out front here. It's giving it 3 times here, and the outcome is that there's 3 of them. Hopefully that makes sense. Okay. So when this one goes away, I'm left with this guy. So I'm just going to put him down here and see where he's at. PO4. Now you should be able to see I got that 3 right here, which was a 3 negative. So that's it. That's all I'm left with. So I'm going to put that over here. PO4, 3 negative. And this guy accepted, so it was neutral, but it accepted 3 times 3 pluses. So it's going to be plus because it has more than enough. Okay? So if I take a look at that, that's how we get the plus, because it had more than just the 1 plus to neutralize it. So this is not neutralized anymore. You can see that they actually have charges. This has more pluses, more of those electrons, and the PO3 is left how it was in its original state as a polyatomic ion with that negative, that 3 negative on it. Okay? So doing this, realizing this right here, where it gives it 3 times, and so the outcome is 3 times, keep in mind, that just helps you balance it. So if you do that on the front end, when you go to balance it at the end, it should be close to being balanced. Okay? So that's that first example. Let's look at the next one. It says, what reaction occurs between H2Cr2O7 and water? So they want to know what the reaction is. So I'm going to look at it and say, okay, this is not my typical acid-base reaction. I've got my H2, but over here I don't have my OH. Okay, so I know it's going to be a little bit different. So I'm asking myself, where is this H going to be donated to? This is my acid. It's going to be given to this base, and it's going to be given 2 times. So keep in mind, the first one that's given is going to change this number. So now I have H3O. Okay? And that's okay to give that one. So it gave the 1, and now it's H3O. And remember, it's because we had this guy. Remember, he came over and went like this. That's how we got the H3O. Okay? And how many times does it do it? Twice. So it gave it twice to this guy, which occurred and created 2 of these